So up next we have a keynote talk by Professor Param Singh. Professor Param Singh is the Carnegie Bosch Professor of Business Technologies and Marketing at Carnegie Mellon's Tepper School of Business, where he also serves as Associate Dean for Research. And the talk is going to be titled something slightly different, so I'll let you take it away.
Thank you. Thank you, John, for introducing me. Thanks, Alessandro, for inviting me. It's always a pleasure to engage with Carnegie Bosch because they have been supporting my research for almost 10 years now. So I was a young faculty when they started supporting my research, and it has played a big role in the kind of work that I do. This talk is going to be it's going to be quite different from what we have seen so far, which was all about large language models. I come from a business school. I study AI from a more of an economics lens. So we look at when the systems are deployed in the real world, what kind of outcomes that we can observe that are going to happen, and then how does policymaker, how should they be looking at these kind of problems? That is the kind of thing that I study, and this particular talk is going to be about pricing. And one of the things when we talk to any kind of business leaders, they're always thinking about AI's use. One of the first thing comes to their mind is pricing. This is something that is where they can use AI. And it is actually has been used for quite some time now. And when we started on this project, one of the first things that we started thinking about is how are we teaching pricing to our students? And in the business school and in economics, we teach pricing in a way that there is a demand curve and there are your competitors. You understand what the demand curve is, you learn about it, look at how your competitors will respond to you, and you solve a complicated optimization problem and you come up with best response to your competitors' prices. That is what the price you are going to choose. But that's not how real world works. Real world is actually, nobody is doing exactly what we have been teaching almost. The real world is actually doing for a long time algorithmic pricing. And when we think about algorithmic pricing, this pricing is of two types. Primarily, if you go on Amazon, you are seeing a price that has been set by an algorithm. You go to Walmart, they are setting a price by an algorithm. And when we think about these algorithmic pricing, they are primarily of two types. One is what we call like there can be many buckets, but let's divide them into two buckets based on the sophistication. One is simple rule-based pricing, and the other is more, which is more widely used or at least widely talked about, and we are starting to see being used, which is like AI-based pricing. What is the simple rule-based pricing? It's actually very simple. You set up a predefined decision rule. You're going to say, I'm going to pick a competitor. I want to undercut my competitor by 5 cents. Whatever the competitor sets, you immediately set your price 5 cents below that. You can say, I want to match the lowest price in the market. Or you say, like, I want to price above my competitor. So you just set up a rule by which you are going to set pricing in the market. Okay? And this is so common. Actually, we're talking to somebody who says pricing at Target. Target looks pricing at Walmart and price a certain percentage above Walmart's price. Recently, you guys must have heard about Amazon's trouble with the Federal Trade Commission and so on, which is one of the things that was talked about was Amazon's project Nessie. What Amazon was trying to do there was quite interesting. It will set its price, it will increase the price up, and then it will go look at what is being done by Walmart and Target. Do they respond by increasing their prices? If they do, they will again increase their price slightly more. If they don't, they will bring down the price. Essentially what they were tracking is whether their competitors were using some rule-based pricing and they could take advantage by raising pricing in the market. Right? If you go to any of the platforms like Amazon, Google Shopping, and so on, all of them are offering this rule-based pricing for free to all the sellers on the market, on the platform. Third-party sellers can choose this pricing strategy to set their prices in the market. And then there are these third-party repricers, salary, and so on, which allow you to do that. But you can easily imagine, these are so simple, this can also lead to problems. Several years ago, you may have known about this particular book called The Making of a Fly. That book should be priced at about $30 or so, but it was priced at $2 million. Because one seller said, I want to price 20% above my competitor, others said I want to price 11% below. And the cycle continues and it went to $2 million or so on that and stayed there for quite some time. And since then, people have become smarter. They will say, no, I want to keep prices within a certain range. Okay? But this is how most of the pricing at this time is exactly this what you see. But more recently, there have been these more reinforcement learning-based pricing algorithms that came up. Several years ago, there was a paper by Alibaba which said they started using this AI-based pricing and they are making a lot of profit. Since then, there has been a lot of interest in trying to study what can we actually use these AI-based algorithms. And these algorithms are actually working the way we have been teaching pricing. They say, okay, let's look at your profit function. We want to maximize your long-term profit. And how would we do this? We are going to do it through price experimentation. Standard ways like through online learning algorithms, you use a multi-arm bandit or reinforcement learning. It picks some prices in the market, sees what return you get, and over time learns to take actions which will give you better prices and so on, and doesn't take actions which give you poor prices. Yeah? Interestingly, none of these platforms like Amazon, Alibaba, Google Shopping are offering this kind of algorithm to the third-party sellers, but at least they claim here and there, not very clearly, that they themselves may be using these. But there are these third-party companies which have started offering these as options to use these AI-based algorithms for the sellers. Now, there was an article like that came out several years ago, about like almost 7 or 8 years ago. This is pre-COVID times, when these AI-based algorithms were starting to be used in pricing algorithms. So this was an article which came out which said like these algorithms may be so smart that they can learn to collude. And this has been a concern for quite some time to see whether they are so smart that they can learn to collude. If they can, this is a serious policy issue. So a lot of research in this area has actually looked at precisely this. Let's look at AI versus AI algorithm. When they compete to set prices, can they come up with a collusive outcome? And the conclusion is yes, they actually come up with collusive outcomes. Most of this work is theoretical. There has been this one study which is empirical I'm not citing it here, but there is one study which is empirical, which showed that in Germany, there were these gasoline stores, and these gasoline stores, all the competitors adopted AI pricing. And suddenly gasoline prices went up 38% in the market. Right? So there are these kind of issues that are emerging. When we started looking at it, that these are like a little bit hypothetical scenarios that AI-based pricing would be used. As I will show, it is still hypothetical in that space. But we went to Amazon. We said, let's say how many sellers are actually using AI-based pricing or what pricing they are doing. So we collected this high-frequency pricing data from Amazon. Every 15 minutes, we collected prices for almost 100,000 products for many, many sellers and so on. And what we find that most of these sellers were using some very simple rules. The pricing patterns look like these. I'm showing you prices of two sellers in case one and case two, and they increase or decrease by the same amount. So you can pretty much say they are following some sort of fixed rule to move up or down. Okay? So this made us thinking that maybe one of the things is that these bigger sellers like Amazon or Alibaba, they may be using these algorithmic pricing or AI-based pricing, but the smaller players are probably using the simple rule-based algorithms only. So essentially, we should be looking at a competition between AI pricing and simple rule-based. Can it lead to collusion, or would it like really kill the simple rule-based pricers out of the market? So that's where we got into this problem. We said, let's study this problem. How does these AI algorithms compete against simple rule-based algorithm? Because that's what is probably happening in the market. So to study this problem, there are two things that is needed. It's still in hypothetical space, means it's more in the simulation space. You need pricing algorithms. You need a demand system which is going to produce some outcomes. Right? So this is the reward model that we think about in terms of in the reinforcement learning space. So let's go quickly over what are these pricing algorithms and what is the demand model in this case. So the pricing algorithm, the one is simple rule-based pricing. As I said, it's very simple, predefined decision rules. we're going to look at the most common type, which is a competitor based. You pick a competitor, you can undercut the price of the competitor. You pick a competitor, you can price above the competitor, or you can match a competitor. Or you can say like this competitor could be a single competitor or some market price. You say, I want to be the lowest price seller in the market. Okay? So that's how you can do. One of the key things you should remember is the price here, what you are doing is you're pegging your price to the competitor. Competitor price goes up, yours goes up. Competitor price goes down, yours go down. Okay? This is an important aspect of this. This keeps you competitive in the market. You are not too far off from competitor. Okay? I'm going to show you some results with this one, which is the most common undercut competitor's price by a fixed percentage. That's what I'm going to show you. But most of the results generally hold with whichever of these strategies you use. Okay? The other pricing algorithm we are going to use is a reinforcement learning pricing algorithm. Okay? So I don't think I need to motivate why this is a meaningful algorithm to this audience, but let me quickly go over to say how we are structuring the pricing problem as a reinforcement learning problem. Think about you have a fixed set of prices that you are going to pick from. Okay? So you put a higher and the lower range, and in between there is a grid. You are going to choose prices out of this. Now, how are you going to set prices? It has to depend on a state. You take you take the whole set of prices that you have observed for the competitor in the last period. So all the competitors' prices from the last period is your state. You observe that, and based on that, you are going to decide what is the price I should take this period. Yep. So just this may look like a very simple setup, but this becomes very complicated. Even if you have just 10 prices and 2 competitors, the number of possible states becomes 110 to the power 2. Number of possible pricing strategies become 10 to the power of 100. And that's what is the big problem in this case. Your pricing strategy is essentially given the state that you observe, what prices your competitors and you picked in the last period. Based on that, what is the optimal price you should be picking in this period. That's what you are essentially trying to learn. Yeah? And this problem is generally solved. You can use a Q-learning algorithm or a deep Q-learning or actor to critique or any of these algorithms you can use to solve. A Q-learning simply works by setting up the rows here represent your state, the columns represent your prices, and then there are Q values in that. Given a state, if you picked a particular price, what is the expected discounted lifetime profit that you will get? So if you learn the Q table fully, then the goal is essentially to go to what state you are in, find which of the columns give you the highest Q value, and you say that is my optimal price. Okay? That's what you do. And generally, we don't know the Q value is essentially your immediate profit plus your discounted future value. If you look at Bellman equation, this is exactly that. We just don't know the value of each. So we pick a price in the market and we observe these values and we keep on updating our Q value itself. You can, how do you pick prices in the beginning? You can use many different sampling algorithms. Most common is some sort of an epsilon greedy. You pick a random price with a probability epsilon and pick the greedy price with probability 1 minus epsilon. In the beginning, you are going to set epsilon to 1, means in the beginning you know nothing. You just pick a random price. And as you learn more, you start exploiting the system more and pick greedy prices more. And eventually epsilon goes to 0. Okay? And at each period, you are observing your reward models, reward results and so on, given the prices and how the state transitions that you use to update your Q values over time. This is how this process works. Yep. Now, the demand model is a standard logit demand model. It essentially says there are 2 products. Products are somehow differentiated. And the quality of the product is A, J there, and then P is the price that you are picking. And mu is how much differentiated the products are. If the products are very, very similar, exactly the same, then there is no differentiation. If they're slightly different, then mu's value will be a bit higher and so on. So we are going to look at 2 scenarios. In one scenario, I will let there to be 2 sellers, and both are going to use Q-learning algorithm to set prices. Okay? In the second scenario, I'll set one seller to use Q-learning to set prices, and the other seller to use simple rule-based algorithm to set prices. Okay? This is a duopoly experiment at this time, but I'll show you some results with if you go with more and more sellers as well. Okay? I'm only going to allow for 10 prices. You pick a price which is your Bertrand Nash to monopoly. Bertrand Nash thinks about two sellers trying to kill each other. What's the lowest price that they can use? That is essentially at a simple way to think about it, that they are super competitive. Now the policymaker says that you should always use Bertrand Nash prices. If you're off Bertrand Nash, that means you are doing some monopoly or some sort of collusion out there. Okay? That's what the expectation is. Monopoly is that you control the full market. You are the only seller. You can set whatever price you want. Okay? You pick a price which will maximize your profit because there is no competition. You extract really good surplus from consumers. Okay? And we run these experiments because reinforcement learning algorithm needs to learn. We run this experiment for a long period of time until your policy stops updating. So you are going to run it for that time. Okay? So let me give you some sense of what you can expect in this case. So some preview before I show you more stuff in this. When a Q-learning algorithm competes with a Q-learning algorithm, what can we observe? You can have any price from a Bertrand Nash price to a monopoly price. Monopoly is the highest price that you could ever charge. Beyond that, if you charge a price, no customer will come to you. Okay? Very few customers will generally come to you. Bertrand Nash, think about, is in a competition, the lowest price you will go to. Beyond that, you will not go at all. Okay? So you can pick any price between this. The regulators say you should always set the Bertrand Nash price. If you're not setting, you are in trouble. Companies always want to set the monopoly price, but not to show that I'm a monopolist, right? And given all the big tech companies struggling with proving that they are not a monopoly, this becomes kind of relevant in this. If you use Q-learning versus Q-learning, your prices are going to be right there almost like 80% off from the Bertrand Nash. Okay? This is the common result that everybody has found across different settings, that these prices tend to be significantly above your competitive prices. Okay? And this is not illegal, by the way. What is illegal is like if these two sellers were to talk to each other and say, let's fix the price. That's called explicit collusion. If you do that, huge fines will happen, somebody will go to jail. Okay? Here the algorithms are never told that you go and collude and set up these prices. They're just on their own figure out this is a good strategy to set up. And that's what is the worry here. Okay? Now if you use a simple rule-based versus Q-learning, that one seller is using simple rule-based, another is using Q-learning, now the prices are actually ending up at really monopoly levels. The Q-learning algorithm will set up the monopoly price, and the simple rule-based algorithm sets the price one step below because it undercuts the competitor. This is going to be like if I set the match competitor price, it will be exact monopoly price that it will take you there. Okay? This says like actually the problem is not AI versus AI, it's actually AI versus simple rule-based. And the logic here is actually, once we got this result, we were very surprised, how is this happening? We spent almost 6 months trying to break down why is Q-learning not going there. Right? And eventually we understood what is going on. So the whole intuition comes from standard thinking in game theory. So pricing, if you think about, is a repeated game. Each period you're setting up a price, the competitor responds to your last period price and so on. In a repeated game, you think about long-term profit. Okay? When a simple rule-based competes against a Q-learning algorithm, simple rule-based is primarily pegging its price to the competitor. Now, this is a strategy, very well-known strategy that we see all the time. It's a tit-for-tat strategy. You increase price, I'll increase price. You reduce price, I will reduce price. You would have observed it everywhere. Every country, when they actually deal with another country, they are doing exactly the same. You put a tariff on me, I'll put a tariff on you. You reduce tariff, I'll reduce tariff. This is exactly tit-for-tat strategy, which is so common that is used because this is the strategy that ensures you don't lose in the competition, whatever happens there, right? So what does it lead to immediately when you do this? The only way you get out of this is when you cooperate. You say, okay, you are doing tit for tat, let me just cooperate and both be happy. I cannot take rents out of you. You cannot take rents out of me, let's just cooperate. This ensures cooperation. Many years ago, there was a professor, Michael Axelrod, at University of Michigan. What he used to do is he will call all the big economists, game theorists, and he'll call them and ask them, can you submit your best algorithm or your strategy that you will use in competition. You'll attract all those strategies and make them compete against each other. And the one strategy that was never defeated was tit for tat. It immediately led to cooperation, right? So this is what precisely this simple rule-based algorithm is doing. It is essentially a variant of tit for tat. Okay? It is very effective in repeated games, and it gets the competitor to always cooperate. And we know that what reinforcement learning algorithm will do, it will find the best response to this strategy very quickly. Actually, it's guaranteed in a static environment to learn the always cooperate strategy immediately. And that's what it is essentially doing. Right? Now, Q-learning learns the best response to this, and that's why you are seeing fully monopoly outcomes out there. Yep. Now, when Q-learning versus Q-learning algorithms compete, so where is the benefit of Q-learning typically comes? It comes because it's experimenting and learning what is the best response. Okay? But when two algorithms are doing the same thing, they are both learning at the same time. They're creating a non-stationary environment. Every time I run a price given a state, I get different results because my competitor is doing something else every period. So it creates this non-stationarity, and that actually makes learning to be very hard. Learning is suboptimal in these non-stationary environments. So Q-learning and what would we get from this? Q-learning is not able to reach that high monopoly prices, but with simple rule-based Q-learning is able to take that. So essentially what you get to see is almost these are complements. If you find your competitor is using these advanced AI algorithms, which are online learning algorithm, you should immediately stop using AI algorithm, go for the simple rule-based algorithm and exploit. As a seller, that's what you should be doing. But as a consumer, you should be seriously concerned. The prices are going to be even more monopolistic itself. Right? Here are some more results I have on this. This is like in the duopoly case. What I'm showing you here is two sellers that are competing. Both are using Q-learning algorithm in this case. I'm showing you the prices. On the x-axis, I have iterations in thousands, how many times we are choosing prices and so on. On the y-axis are the prices. Then I have two dotted lines. At the bottom is your competitive price that the regulators think you should be using. And on the very top dotted lines is the monopoly price. The Q-learning algorithm, like it's early on prices will slightly go down, then they come up, then they stabilize somewhere. Like between closer to the monopoly price, but not at the monopoly price. But the key part to see also is this, how many iterations it is taking. It is probably like it stabilizes around like probably 300 to 400,000 iterations. That means 300 to 400,000 times you have to do price changes. This is not typically what you can allow generally on most of the platforms. So this is probably still in the hypothetical space there. Okay? When you use two sellers, one of them is using simple rule-based, other is using Q-learning algorithm. The two sellers' prices are shown immediately, you say very quickly. Q-learning goes to monopoly price, and the rule-based goes one step below that. And look at the number of iterations. Probably like 20,000 iterations or 30,000 iterations, you are pretty much at the equilibrium out there. Okay, so very quickly this thing happened in this case. And the profits actually for both of you are higher in this case. Okay? Now I'm going to show you one quick kind of a simulation. We're trying to say exactly what is going on because these algorithms become very complex. And making sense of that, we were struggling. So what we did is we created a short video to kind of track what is happening, how the prices are being picked and so on. So here what I'm showing you is on the x-axis, I have seller 1 using Q-learning. The lowest price he can pick to the highest price. Y-axis, I have seller 2 who is using rule-based from lowest price to the highest price for seller 2. Each of the dots is a price pair. Okay? I'm going to play this. This will be a video almost. What would happen in this? There are these dots. Dot size would increase, telling us how many times that price pair is being played. And then there are these arrows. They are pointing to what is the greedy action given the state. And when the dots increase, you will see some colors. If the color is dark red, this means monopoly. If it is towards the white, it means it is more competitive. Okay, so let me play this and see how orderly it goes. This is Q-learning versus simple rule-based. Okay. very quickly, everybody immediately starts going to the monopoly price almost. They're very orderly. Within like probably 10% of the learning, it will quickly go there. Now let me show you what happens when we do Q learning versus Q learning. Okay. How do I go? Okay. This is Q learning versus Q learning. Here, the only thing I changed is this is the Q learning algorithm here. Okay. Earlier it was rule based. Now see what happens. I will break it down into 2-3 steps. In the beginning, you know that your competitor is picking prices randomly. What are you going to learn? When your competitor is picking prices randomly, that means future does not matter. He's not responding to your strategy. He's just picking randomly. So you only care about short run. In the short run, you are always better off picking low prices. And that's what you will learn. You will see most of the prices will happen here. Okay? Okay? You see most of the action will be happening right here kind of thing, and these dots will become bigger. Let's stop somewhere here. And what it has learned now is that low prices are really good, medium prices are okay, top prices are very bad. When you pick a very high price, competitor is picking randomly, you will learn that I'm getting very bad rewards. So what you have learned very early on, these are high Q values, medium and very low Q values in the beginning. Let's continue this learning. Now what would happen is, now because you have learned low values are very good, both of them are going to pick low prices more often. Now you say, oh, low price Q value is not very good. This is also you will learn when you pick, because your competitor instead of random is picking low prices now. Hold on, I actually restarted this one. Okay. Okay, here it continues on and it learns after this time that these prices were not good. And once the Q values for low prices go down, it goes to the mid-level prices. Now from mid-level prices, can it go to the high-level prices or not? That's the question. Like eventually, can it learn that high prices are really good? And generally it does not learn that part. It will get somewhere stuck around here. And let me see if I can, what is happening? It will get stuck somewhere here. The reason that happens is this. In the very beginning, you learned that high prices are very bad because your competitors were picking prices randomly. You never get to explore that part of the region on the top right, which indicates that which is the best outcome for you. You never learn that because of non-stationary environment. And that's where this situation ends up happening. So is this result very common? What we found that we could not break this result at all. We tried so many different combinations, like we tried different demand models. What if this, we take, Amazon has this buy box policy. If there is a buy box model that you put in the demand, actually this is even more stark difference there. Okay? You can make it like increase differentiation, reduce differentiation, result does not go away in this. In fact, we found like almost, there is only one situation we found where using Q learning may be advantageous compared to simple rule-based versus Q learning. And that's the only thing that we found was that if the competitor does not care about the future, okay, when the discount factor, the future doesn't matter, each period you are thinking about maximizing your reward, then the long term doesn't really matter. And this tit for tat is a good strategy when people care about the long run. Otherwise, everybody would just go and do super competitive outcomes. Tried different reinforcement learning algorithms, different simple rule-based algorithms, mostly results are same. There are these different algorithms. Let me show a couple of results on this. If you use the different algorithms, one is like you want to undercut the lowest price in the market with a minimum, that you are not going to go below a certain limit. Or you say, I will just target the lowest price. Whatever is the lowest price, I'm going to match it. Or you say, I want to target the lowest price with the minimum. Okay, those could be used. You could also use this simpler strategy. Is it only simple strategies which compete very well, or is it a tit for tat strategy? Simple is like you could just fix a price. Would the algorithm, then AI algorithm, just collude with you in that case as well, right? So you could fix the high price or a low price. So here are some results I'm showing you. Here are two of the sellers. This is again prices I'm showing. The competitor is in gray and the focal seller is in red. Focal competitor is always using Q-learning. Here the focal seller in the worst case is using undercut lowest price with the minimum. Then target lowest price with the minimum. And you have fixed low price and fixed high prices. And this dotted line is the QQ scenario. Both of them use QQ price. In this case, what you will see now is any of these simple rule-based prices. The prices are much higher compared to the AI versus AI prices. Whereas when you go to the fixed rule-based prices, fixed low price, the competitor cuts you even below the low price. Fixed high price, competitor again undercuts you with Q-learning algorithm with low prices, and your profits are kind of worse off. So if you use fixed prices, the AI algorithm will take you to cleaners completely. You are going to be like losing a lot in the market. So you need to use a little bit of this tit for tat kind of variance in the market. And that's how like these are profits I'm showing for the same things. And you can see profits are much higher when you use simple rule-based algorithms. Okay? Some results on differentiation here, like if there is, here I'm showing if there is more differentiation, what happens. Yeah? The dotted line at the bottom is competitive price, and on the red, the line is showing us the monopoly price. And those are like your Q-learning algorithm prices that I am showing you. With this, you can see that the dotted is actually not monopoly. Dotted is the red line on top is simple rule based. Okay? The Q-learning prices are shown as a box whisker plot. Just as the differentiation increases, the gap reduces. What does it mean by differentiation increasing? The two products are so different that the consumers are not thinking them as competitors. When that happens, competitor price doesn't matter. Right? So that's how you should think. What about if we have multiple sellers? Now, generally, a lot of these algorithms work very well when you have two sellers. What if there are 5, 10 sellers and so on? So we did a number of studies on this. Let's say if we have 5 sellers. And we set up, I will show you one scenario where seller 1 is using Q-learning. Seller 2 is my focal seller. In one case, we will use Q-learning. Another case, we will use simple rule-based. And seller 3, 4, 5 are all using simple rule-based algorithms. Okay? Here is what the outcomes will come up. I'm showing all the 5 sellers. The red and the blue on top, those are the Q-learning ones. And the black one is the 3 rule-based sellers. Okay? The prices stay between monopoly and Bertrand price there. What if seller 2 now switches to simple rule-based? When that happens, then in the market there is only one Q-learning algorithm. Everybody else is using simple rule-based. And the prices again go back to the monopoly. Yeah. So this, what does it tell us? Actually, what is this telling us is interesting. In the market, just for the sellers, the best thing is to have one seller using AI-based pricing, everybody else using some sort of a rule-based pricing. And this is probably what may be happening in the market, because this seller who uses Q-learning algorithm can basically control the market and set the prices at the level that they want. Right? So if you are Amazon and you want to kind of set prices medium level, you use Q-learning. Everybody else use rule-based and you set the prices at medium level, because everybody is pegging the price to you. And the profits are quite significant here, about 12% more profits or so on. Okay? Let me summarize what overall we are saying here. From a seller's perspective, a lot of sellers, like given that we are in a business school, more applied economists, our audience generally tells to be the marketers who want to set prices. When they come, our suggestion is generally that don't fall for, when you see competitors using more advanced algorithm, use very simple rule-based algorithm. That's when you are going to get the best outcome out there. Right? And the other part that we need to think about is AI versus AI competition directly in a market probably is not the best idea. Because the benefits that they gain are from experimentation, this more exploration, exploitation. And when all of them are doing this, it's non-stationarity hurts. You should go back and think of simpler strategies to take advantage of this kind of a more advanced behavior of AI algorithms that can actually help you get better outcomes out Now for consumers, your surplus is going to be fairly low when this happens. Basically, all of your surplus is taken by the sellers if they start using simple rule-based versus Q-learning algorithms. And for policymakers particularly, this is like this work has got a lot of attention from the policymakers. I get invited to talk about this a lot. Is that a lot of focus has been on collusion by AI algorithms. And what we are saying, that probably may not even happen in the real world for long, because there is a better outcome before that, where the AI algorithms compete with what is the most common algorithm right now, which are simple rule-based algorithms. If that competition happens, there is no incentive for sellers to go and invest in these AI algorithms broadly. Okay? That's where I think I will stop, and I'll take any questions. Yeah. Thank you.
Hi, great talk. I had a question about a thing you said at the very end, actually.
Yeah.
So you pointed out possibility that the incentives for using AI here are not as much as they may seem. What that immediately made me think, though, was this very common perception that AI is the way of the future for almost anything. I can imagine vendors buying into that. Do you have any comments on that, just the perceived utility getting out of hand?
Yes, so the way we think about as from perspective, your point is very good. It's very hard to convince vendors to not buy AI algorithms. In fact, many of the vendors we talk to, they actually are more about my competitors are using it. I have to use it, otherwise I'm going to lag behind. And generally the way we think about it, yes, they will buy and they will see their results are going to drop, their profits are going to drop, and that's when they will shift back. They'll say, I was better off using the simpler algorithms in that. Now, when the other point that you are saying AI is the way of the future, that I still believe is the case. In fact, if there was no seller using AI algorithm, then the outcomes are not as good. Amazon consistently struggled with this case where like prices, everybody was picking to undercut each other and prices were going too low. So Amazon has this strategy called jackknife strategy. What it does is if you adopt it, you will increase your price, like randomly increase price. You pick this, buy into this strategy in middle of the night, it will randomly increase your price and see where the competitors also increase the prices, right? To ensure that they are not undercutting, everybody is not undercutting each other. So without AI, you're not going to get that outcome. So AI needs to be there and somebody needs to be using that for sure.
So one question. So in the simulation environment, so you're typically assuming that the state observation is perfect, right? So you can perfectly observe the state. Whereas in a realistic scenario, if I'm Amazon, I might want to throw off my competitor, right? So the state observation itself might be noisy or maliciously crafted.
Yes.
So how do these results translate in that scenario, right? And
okay,
does that actually happen in practice?
In this case, the state is set up as last period prices that you do observe, but let's say there is some way you are creating some noise in the system. There is more complex state that we don't observe. The more complex the state becomes and more variability in the state is there, like to throw off people. In the Q-learning algorithm, you're adding even more non-stationarity. Now it's not only that I don't observe your state, what I observe is probably not the correct state. So Q-learning versus Q-learning becomes even worse. So you are better off with Q-learning versus simple rule-based, even in that case. The gap even increases. In fact, if you make the Q-learning algorithms or AI algorithms even more sophisticated, they become worse. One way we know that how to break this collusion by AI versus AI is to make them way more sophisticated. Like you do some sort of a competitor modeling, that I will learn also about the competitor, what they have tried out, what they may try this time. You model that, it becomes even worse. That then the simple rule-based allows you to get even better results with that. Yep.
Somehow connected to what Shalab was saying. So, you know, there is this notion of transition, so between states. And, you know, the way, so how do you unfold the notion, the variable that stands for state in this domain, right? Because a state can be many things, can be very complex.
Yep.
I think in all your examples, you mention, of course, the situation where you have a stakeholder, a competitor, they fix a price, and then those prices vary.
Last period prices that you
Right,
observe
right.
as state. Yeah.
But then, of course, depending on the state of the world, the
Yeah.
reasons for changing the prices may also
Yes.
vary.
Yes.
And I'm wondering again, this is more a clarification question. How do you account for, let's say, arbitrary complexity of the state of the world when you make these decisions?
Yes. Oh, this is a great point. So the way we think about it is, let's say the market environment is changing somehow, and you can't predict it very well. That changes like randomly almost. Some period it will be, some of the demand comes up very high, sometimes months, some period demands come very low. So you can model that as part of the demand model itself, that some component of the demand model is completely arbitrary, coming from some distribution. And you don't know that distribution, and that will produce. I think I may have some result with that. Let me see. Oh, this is where it is. If there is demand uncertainty, so the idea is like, the way we do it in the demand model is like there is some outside good and it has become valuable suddenly that you were not considering, right? Or income shock comes to people. Suddenly like stock market goes down, nobody wants to purchase, let's say that period happens suddenly, right? If that happens, this factor is going to, A0 is going to capture how much uncertainty impact is there. The more uncertainty happens, you can see the red one was still your with rule based, and the blue box whiskers are your Q-learning algorithm. The gap keeps on staying. The only time the gap kind of disappears if your discount factor means the future you don't care much about at all. That's when the results become kind of exactly the same, because you want to set competitive prices.
Maybe a naive question, but so you said explicit collusion is a crime and bad
Yeah.
things happen, but you've called all of these examples collusion as well, which I think we can agree to.
Yeah.
So then the question is, what can we do about it? Like, how do you actually regulate this kind of AI pricing schemes to avoid what we're colloquially calling collusion?
So right now this is called tacit collusion. Now tacit collusion means like prices set up, prices come in the market, and you can't kind of, people have not talked to set up the prices, but they are above competitive price. The challenge is with, when you see it in the real world, these prices, you will not be able to tell that they are actually collusive prices or competitive prices. This is extremely hard, complicated problem to solve. And kind of no court will buy just that you show these prices that they are collusive prices. The companies can always say my marginal cost is very high. Right? I have to account for that, and that's why my prices are so high. Now there is a lot of discussion in FTC, particularly related to how should we regulate these. These are largely discussions currently. One of the discussion that is going on is we should ban any kind of algorithmic use in pricing, which I don't think is a good idea. If you do that, then actually the consumers are going to be eventually worse off, because the prices are not even going to be competitive in that case. Just to be competitive, you need to observe and respond to competitive prices, right? There is no easy solution, but there is a lot of discussion on this.
And I guess like tying back to some of the talks a little bit earlier, right? So the difference between explicit and tacit collusion is whether or not there's an actual communication going
Yes.
on, right?
Yeah.
But you can imagine it, especially as more powerful models get to set these prices, right? The pattern with which you change your prices might actually be akin to explicit communication as far as these models are concerned, right?
Yes.
You can identify what the other model is doing and understand what is the correct thing to do now, which is to just go full on
Yes.
collusion, right? So I guess is there any hope here that we avoid?
Let me say, see, this is a good point you are saying. Let me say, what you are essentially saying is the way I'm setting prices, I'm giving you a signal. The list collude. Actually, that happens even without algorithms. If you look at most of these pharmacies which set prices, there was a recent study which came out which said like they tracked how frequently pharmacies change their prices. Some will change prices every hour, some will change every 4 hours, every 6 hours, every 30 minutes. The second you fix your time on when you will change the prices or how frequently you will change the prices, and you commit, you are not going to change prices every 15 minutes. Some is saying 1 hour, some is saying 4 hours. That actually takes you towards more collusive outcomes. So that's a very good observation in that the way I'm setting prices, I'm actually giving you signal what I'm looking for. Why don't you cooperate with me? And that's where it is a challenge also to like, how do we stop it, even if there is no algorithm? This is not an easy problem. At least currently the government has been thinking that we should ban any algorithm use, which I don't think is a good idea so far.